wire is connected to a sensitive meter. Explain why the meter, it's not specific, whether it's a galvo, a voltmeter, an ammeter, shows a brief reading when a magnet is pushed into the coil. So, let's jump across. So as we push a magnet into a coil, you can imagine you've got here, you've got your magnet, so make that the North Pole. Here's your coil, you're pushing it in. Now, the magnet has a set of magnetic field lines around it. For a bar magnet, it's going to look a bit like this. And it's north, so all those field lines will be coming out of the north, going into the south. So it'll look a little bit like that. And as I push that magnet in, this coil, made of a conducting material, is going to be cutting those field lines. So, and that will induce an EMF across the coil. Now, the other way is exactly the same principle, by saying it's what it's doing is its flux is changing as it's actually getting pushed into the coil. So, write it down, pushing the magnet into the coil means the coil cuts some magnetic field lines. So that's going to be changing the flux, and we know obviously that the induced EMF is minus n d phi by dt. So changing that flux, cutting the field lines, however you describe it, will therefore induces an EMF across the coil, by which I mean between this point here and this point here, and would induce a current if it is a complete circuit. So if I had a voltmeter from here to here, there would be no current through this coil, because a voltmeter, or an ideal voltmeter, has an infinite resistance, so there'd be no current through the coil. However, if I put an ammeter between these 2 points, there would be a way for the current to flow all the way around, and I'd actually see a reading on the ammeter. Thank you very much.